Here we're going to look at how to use a graph to solve an equation. So part A, they're asking solve or telling to solve negative 3x plus 20 is equal to 5 by graphing. And then we have this statement here. An equation is a statement that two expressions are equal. The value of x that make the equation true are the solutions. To solve an equation by graphing, write two new equations by setting y equal to each side of the original equation. So what you can do is you can take the negative 3x plus 20 equals 5 and create two equations. One where we take the left and say negative 3x plus 20 is equal to y, and the second one where we take the right and say that y is equal to 5. So you take the negative 3x plus 20 and create an equation, and then the 5 and create its own equation. And you can graph these by hand. You can actually solve this equation by hand, but we're just going to go through the graphing method so that we have an idea of what that is like. So to do this, you would graph the two equations and identify the points of intersection. These points will have x values that produce the same y values for both expressions, and each of the x values is a solution to the original equation. So you could, again, graph this by hand. You could even solve this by hand, but we're going to use the graphing calculator. And on the right here, we're going to start by going to y equals, and I'm only going to type one equation at a time for now. You can do both of them at the same time, but just for practice purposes, I'm going to start with the first one. So I'm going to type in negative 3x plus 20, and now I have my first equation. The next thing I'm going to look to do is I'm going to click the graph button on the top right, and that'll give me a graph of kind of what this looks like. Now, that graph does not look like the graph that I have here, but that's okay because we can go to the table and pick some values. So what I would then do is, instead of looking at the graph, I'm going to hit the second key and then hit graph again, which will bring me to the table. And I'm going to pick a series of points that will be able to be plotted on the graph that I've been provided. So if I look at 0, 20, I can actually go back. 0, 20 works, so let's start with that. So 0, 20, we're going to plot. And I can just pick some more points, maybe 2 and 14. When you're first practicing this, more points the better. But as you get a bit better at this, you'll start to see which points are going to be more useful. 5, 5, so I'll use that. That's an easy point to graph. I'm sorry, that should be, 2, 14. 5, 5, and then the 7 and 8 are in the negative range, so I'm just going to stop with 6, 2. That'll be a good point to stop on. And I actually graphed that 5, 5 spot wrong. That was 5, 10. So 5, 5 would actually be right here. So now I have a graph that I can shape, so I'm just going to play connect the dots here, draw a line through my points, and I have an accurate but not perfect graph of y equals negative 3x plus 20. Now in terms of the y equals 5, there's no x here, so y equals 5 is just going to be a horizontal line straight through the value of 5, the y-intercept of 5. If you're looking at the graphing calculator, you can go back to y equals, go to y2 and type in a 5, and then if you graph it, you'll see that you get that horizontal line. And if you go to the table, you'll see that all the y2 values are 5. So we have that there. Now your solution is going to be where these 2 points intersect. So our solution is going to be looking right here, and we're going to look at these points will have x values that produce the same y values for both expressions at the points of intersection. So each of the x values is a solution to the original equation. So that coordinate point is 5, 5. Well, your solution is the x value. And so all I'm going to have to say is that x is equal to 5. What you want to do is you want to graph each equation or each part of the equation, create them as separate equations, graph them, and then find their points of intersection. I'm going to jump right into B. I'm not going to go over A too much more. I want to look at B so we can see both of these in a little bit more detail at the end. So part B, we're going to again solve by graphing. This time we're given the absolute value of x minus 4 is equal to 1/2 x plus 1. So I take the left side, this x minus 4, and I'm going to create my first equation of y is equal to the absolute value of x minus 4. And the right side, I will write as y is equal to 1/2 x plus 1. So now going back to our graphing calculator, we go to our y equals screen. I'm going to clear out the old problems. Sometimes this will end up happening where it doesn't let me use certain portions, so I'm just going to close that out, reopen that calculator, and there we go. We can use y1 again. So for the first one, which we have shown in blue here, we need the absolute value of x minus 4. To find the absolute value on the calculator, you're going to hit the math key, which is on the left side under the alpha key. Scroll to the right to the number list, and then option 1 is the absolute value. So I'll select option 1, and now I can enter an absolute value. So I'm going to type in x minus 4 as my y1 value. Again, you can do both of them at the same time, but I'm going to do one at a time. So I'll hit graph, and I have a graph that looks like this. It looks like I have an x-intercept of 4 and a y-intercept of 4, so those are some good guiding points. But to be more accurate, I'm going to hit second graph to bring me to the table. You do want to be careful with this graph. On the sheet, it goes up by 2's, so just keep note of that. So -2, 6, I can use that point. I'm going to skip -1. I'm going to go to 0, 4, 2, 2. So if you want to plot more of these points, you can pause this for a second, kind of plot more of these points. You can see them on the screen, but I'm going to go through that kind of quickly so that, just for the sake of saving a little bit of time. So 6, 2, 8, 4, and then if you needed to scroll on your graph, you could scroll for more points here. 10, 6, 12, 8, and 14, 10. So play a little game of connect the dots. And we have our absolute value function. I'm going to do the same thing. I'm going to go back to y equals, but this time I'm going to use a second equation, the y 1/2 x plus 1. Anytime I'm typing in fractions on the calculator, I recommend using parentheses. That way, order of operations don't become an issue. Calculators are never wrong. It's just a matter of us putting in what we intended to put in. So we have to be careful when typing equations, especially with fractions. So we're going to do 1 divided by 2, and then close my parentheses. Again, anytime I have a fraction, I like to put that in parentheses. And then x plus 1. If we hit graph, we see what our graph should look like. So I have this red line going from the bottom left to the top right. So I have a positive slope, and it looks like it intersects at 1 on the y-axis. So again, just some guiding points. So I'm going to go second graph to bring me to my table. Again, I'm going to be kind of selective about the points I use. I'm going to avoid the decimals because it's just going to be easier not using them. So I'm going to start with -2, 0. So that would be right here. And then 0, 1 works for me. Although actually that's not a number, so it's going to be in the middle of a point. So I'll actually skip that one. I'm going to go to 2, 2. So that's a good one to use. 4, 3, I'll skip that. 6, 4 works for me. And I'm just looking for ones that are going to be easy to plot. 8, 5, we could use that if we wanted to. 10, 6, it's a little bit easier. And then let's go with 14, 8. That'll make the most sense. Right, so we have our points. Again, if you wanted to pause that and fill in the rest of the points in your own time, that's fine. But just to save a little bit of time, it will continue moving along. So we have our points, we have our graph for the left equation, we have our graph for the right equation, and now we have our intersection points. Notice that there are going to be 2 of them, so I will have 2 solutions in this case. This first point has a coordinate point of 2, 2, and this second one is 10, 6. My solutions, again, are the x values for those coordinate points. So I have a solution of 2, and a solution of 10. So x equals 2, x equals 10. And that's how you would solve equations by graphing. Now, one of the things I highly recommend you do using the graphing calculator is if we look at part B, we had solutions of 2 and 10. If you go back to your table and scroll up to the x value of 2, notice that your y values are the same. That's a good signal that you have the right answer for 2. And if I scroll down to an x value of 10, I have y values of 6 and 6, so they're the same. That's kind of my signal or my sign that those are my solutions. We do want to use the graph to get an idea of where we should be looking, but you can use the table to find the solutions pretty quickly. All right, that's it for example 1 here. Hopefully that makes sense, and you can give that some practice.